So in chapter 3, are going to be looking at stoichiometry. So we're going to be comparing amounts of our reactants to our products. But before we get to that, we want to talk about the amount of a substance using the unit mole. So the SI unit for amount of a substance is mole. And we're going to, it's just used as a counting unit. So kind of like how we use a dozen. A dozen of anything is 12. That's the same idea for the mole. So just to give you an idea, 5 mils of water contains 2 times 10 to the 23rd water molecules. So the mole allows us to work with smaller numbers. Instead of saying 2 times 10 to the 23rd water molecules, that's a lot of molecules, we can use moles. And again, you're going to be using a smaller number that way. So Avogadro's number is 6.02 times 10 to the 23rd. You will need to know that number. And it is equal to 1 mole. So again, think of it like a dozen. So if I have 1 dozen of something, I have 12. Well, if I have 1 mole, then I have 6.02 times 10 to the 23rd. So 1 mole of helium atoms is 6.02 times 10 to the 23rd helium atoms. 1 mole of carbon dioxide is 6.02 times 10 to the 23rd carbon dioxide molecules. 1 mole of elephants is 6.02 times 10 to the 23rd elephants. So like I said, just like we use the dozen, I can have a dozen eggs, a dozen pennies, same idea. It's just a quantity, but it fits perfectly for chemistry because atoms, we work with so many atoms in a sample or molecules in a sample, and it just makes the number smaller for us. So we're going to be using Avogadro's number as a conversion factor. So we're coming back to dimensional analysis here, but it's just a new conversion factor. So nothing new, just using it. Okay, so we have 6.8 moles of nitrogen, and we want to know how many nitrogen atoms there are. Oops. So we are going to start with our given, which is 6.8 moles. Actually, I'm going to take away that E. Okay, 6.8 moles. And we want to set it up where moles is going to cancel. So I'm going to put 1 mole on the bottom and 6.02 times 10 to the 23rd nitrogen atoms on the top. So moles will cancel. And then that gives me 4.1 times 10 to the 24th nitrogen atoms. So again, we already have done these dimensional analysis steps, but we're just adding in this new conversion factor. So on the other one, we're going to go from atoms to moles. So it says we have 5.87 times 10 to the 24th atoms of helium. Actually, I'm out of room here. Let me come down here. So 5.87 times 10 to the 24th atoms of helium. We want to know what that is in moles. So I want atoms to cancel, so I'm going to put Avogadro's number on the bottom. And 1 mole on top. So atoms are going to cancel, and that gives me 9.75 moles of helium. Okay. So just to give you an idea of what a mole looks like, all of these samples represented here is 1 mole of a substance. So the only difference between the 1 mole of the substances is the mass of the substances. So you can see in the picture, I'm pretty sure the first one listed there is copper, and then actually I'm not sure what the next one is. Aluminum. So this one is copper, this one's aluminum, sulfur, and then these are compounds over here, but there's still 1 mole. And again, the only difference is their weight, their mass. So we're going to compare the moles to the mass of an element. So the mole is defined as, or the standard for the mole, I'm sorry, the amount is 1 mole of carbon-12 is exactly 12 grams. So that's our standard. So if you have your periodic table, if you look up the mass for carbon, it's 12, okay? But then if you go to copper, look at the mass for copper, it's 63.55. So those masses on the periodic table represent the mass of that element per 1 mole of that substance. So really, what it looks like is down here. It says copper is 63.55. So 63.55 is the number you're going to see on the periodic table, but the units are grams per mole, because that means 1 mole of copper weighs 63.55 grams. And then over here, 1 mole of aluminum weighs 26.98 grams. So we just use the units grams per mole. And then here, sulfur is 32.07 grams per mole. So all I have to do is look at the periodic table and it will give me the molar mass of each element. So again, that number is per 1 mole for all the elements. Okay, so we're going to use the molar mass as a conversion factor. So here it says how many moles of copper are in 22.5 grams of copper. So we just saw that 1 mole of copper is equal to 63.55. Oops. 63.55 grams. Okay. So again, we're going to use that as a conversion factor. Okay. So we're going to start with our given, which is 22.5 grams of copper. We want grams to cancel, so I'm going to put 63.55 grams on the bottom and 1 mole of copper on the top. So we get 0.354 moles of copper are in that 22.5 grams of copper. Okay, then the other one says how many grams of aluminum are in 3.8 moles of aluminum. So again, we saw that for 1 mole of aluminum, it weighs 26.98 grams of aluminum. So again, I'm getting this number here from the periodic table. Okay, so we're going to start with our moles, 3.8 moles. And we want to go to grams. So I'm going to put moles in the bottom, 1 mole of aluminum, 26.98 grams of aluminum. So moles of aluminum cancel, and I get 1 times 10 to the second grams of aluminum. Okay, now let's put these two conversion factors together. So we can go from grams of grams of an element to atoms of an element, but we have to use both of the conversion factors. So I like to write this right here. So we can go grams to moles. Well, let's do it this way. Grams to moles using molar mass. And then we can go moles to atoms using Avogadro's number. So it's kind of helpful. Okay, we can't go straight from grams to atoms. It's not how it works. We have to go through moles. And same way, we can't go straight from atoms to grams. We have to go through moles. Okay, so let's try this first one. We have 9.65 grams. Uh-oh. Sorry. I touched something I wasn't supposed to. Okay, 9.65 grams of silver. And we want to know how many atoms. So first we're going to go grams to moles. So you have to look up the molar mass for silver. And when you do, you should find that silver weighs 107.87 grams per 1 mole, right? Because molar mass is always per 1 mole. So we want grams to go on the bottom. Moles in the top. So grams will cancel. But we're going to keep going because it wants atoms of silver. So I'm going to come down here. So I'm going to use Avogadro's number now. I want moles to cancel out. So I'm going to put 1 mole of silver on the bottom. And 6.02, 10 to the 23rd atoms of silver on the top. So moles are going to cancel. Okay, and that gives me 5.39 times 10 to the 22nd, oh goodness, 22nd silver atoms. Okay, now let's do the other one. So this time we're going to go from atoms to grams. So we'll start with our 4.89 times 10 to the 22nd atoms of sulfur. Okay, so we want to use Avogadro's number first. We're going to go Avogadro's number. That'll get us to moles, and then we can go moles to grams. So we want atoms to cancel, so I'm going to put 6.02, 10 to the 23rd. Sulfur atoms down here, and then 1 mole of sulfur up here. So atoms cancel, and then now we can go moles to grams using molar mass. So the molar mass of sulfur is 32.07. So again, you just look up that number on the periodic table. I want moles to cancel, so I'm going to put 1 mole of sulfur in the bottom, and then my 32.07 grams of sulfur in the top, and that gives me 2.61 grams of sulfur. So far we've only done elements. But you know, mostly what we use in the lab is going to be a compound. So we want to do the same thing, but now we're going to do it for a compound. Okay, so here we have formula weight and molecular weight. The only difference between the formula weight and molecular weight is formula weight is for for an ionic compound. And molecular weight is for a covalent compound. But it's exactly the same thing. So honestly, I just always call it molar mass of the compound. And I don't specify with molecular weight or formula weight, I just say molar mass. Okay, so to find the weight of a compound, first we have magnesium here. And there are 3 magnesium. So what you need to do is go to your periodic table, look up the weight for magnesium, and you'll find that it's 24.31. Okay, but you have 3 of them, so you've got to multiply by 3. And then we have nitrogen. There's 2 of them. So if we look up the weight for nitrogen, it's 14.01. And we have to multiply that by 2 because there's 2 of them. So 3 magnesium and 2 nitrogen add up to be 100.95 grams per mole. And it's still per 1 mole. So what that means is if I have 1 mole of magnesium nitride, then it's going to weigh 100.95 grams per mole. So always use 1 mole for molar mass. It doesn't matter how many atoms are listed in the compound, always 1 mole. Okay, then we also have water, so 2 hydrogen. So hydrogen is 1.01. We multiply it by 2. And then oxygen, we only have 1. And oxygen weighs 16. So you don't have to multiply that by 1. And then we add it up, and the weight of water is 18.01 grams per mole. And again, that's just 1 mole. So if I have 1 mole of water, it's going to weigh 18.01 grams. Okay, so next we're going to calculate the molar mass of these compounds. So you're going to need your periodic table so you can look up the weights for each element. So first is magnesium. So magnesium weighs 24.31. So 24.31. We only have 1 of them, so we don't have to multiply it by anything. And then chlorine, there's 2, so we're going to multiply that by 2, and the weight of chlorine is 35.45. Okay, so the weight of magnesium chloride is 95.21. Oops. Grams per 1 mole. Okay, 95.21 grams per mole. Okay, then aluminum. So we have 2 aluminum, so we're going to multiply by 2. The weight of aluminum is 26.98 grams per mole. I'm going to leave that off though because it's making me not have enough room. And then we're going to take sulfur. There's 3 sulfur, and sulfur weighs 32.07. 32.07. And that gives us 150.17 grams per mole. Okay, next one we have calcium nitrate. So we only have 1 calcium, and the weight of calcium is 40.08. Oops. 40.08. Okay, so now here we have 2 nitrogen, right? So anything outside the parentheses has to be multiplied by that, or anything inside the parentheses has to be multiplied by that 2. So we have 2 nitrogen, and nitrogen weighs 14.01 grams per mole. And then we have 6 oxygen. So we take 2 times 3, gives us 6 oxygen. And oxygen is 16 grams per mole. So we add those up, and our compound calcium nitrate weighs 164.1 grams per mole. Okay, last one. Start with nitrogen. So here we have 3 nitrogen, because we're going to take 3 times 1. So 3 nitrogen. Nitrogen weighs 14.01. And then we have 12 hydrogen. So we're going to multiply 12 times 1.01 is the weight of hydrogen. There's only one phosphorus, and it weighs 30.97. And then we have 4 oxygen, and oxygen weighs 16 grams per mole. So the weight of ammonium phosphate is 149.10 AMU, or I'm sorry, not AMU, grams per mole.